Hello and welcome to the computer programming course. I'm Samriddha and today we'll be looking at lab sheet 1 which covers the basics of Unix and file and directory commands in Unix. So what is a computer? A computer is a device that takes data as input, does some processing and then returns an output. The block diagram explains it in detail. Uh, it takes in an input, it goes to the CPU, which has the control unit and arithmetic and logical unit. It communicates with the memory, and after all the processing, it gives us an output. So throughout this course, we'll be writing a lot of programs. So when you write and save a program, where does it actually go? It goes onto the disk, which is a kind of secondary memory, which is not volatile. The examples would be your hard disk drives and solid state drives. So when we want to execute a program, we load it into the RAM, which is volatile memory but allows faster access. And then it is executed on the CPU. So as you might imagine, a computer might have a lot of different hardware resources such as disk, RAM, CPU, input output devices such as keyboard, mouse, printer, etc. So you need a manager to control and coordinate all of these different hardware and software resources that you might have. This manager is called the operating system or the OS. In essence, the operating system is a specialized program that controls and monitors the execution of all other programs that reside in the computer, including application programs such as user written programs, MS Word, MS Excel, Paintbrush, etc. So the main responsibilities of an OS include memory management, processor management, meaning which program runs when, device management, which means keyboard, mouse, printer, Ethernet card, whatever is connected to your computer, security by the means of a firewall, like not allowing unauthorized programs to run on the computer, and finally coordination between other software and users. So an OS might support multiple users, so how would you coordinate between them? Those sort of things. So the next section is a brief introduction to what Unix is, which you may read at your leisure. We'll jump to here. Uh, Linux refers to a flavor of Unix which is freely available, which is truly open source. A few variants of Linux include Ubuntu, CentOS, Red Hat Enterprise Linux. It generally supports graphical interfaces along with a command line interface. So for all our laboratory sessions, we will be using Ubuntu. It is again free and open source, and it is very simple for first time users to use. At the heart of any Linux distribution lies the terminal. So in today's lab, we'll be exploring the terminal and try out a few different commands. So now we'll have a brief look into the Unix architecture. Let me zoom in into it. So at the deepest level, we have the hardware, which is the bare metal processor and IO devices. Then we have the kernel. It is the heart of the operating system and performs most of the vital tasks like task management, file management, and the like. Then we have the shell. The shell allows the user to interact with the kernel. So on the shell, you can write commands. These will be interpreted and then run. So for a basic example, if you say echo hello, it prints out hello. So what did the shell do? It saw echo and thought that okay, the user is requesting me to type out hello into the print stream, and thus it returned hello. And then at the outermost layer, we have application programs like mail, your FTP servers, your databases, this, that. So commands and utilities, you will be learning a lot of different Unix commands throughout these first two labs. Some of them are like cp, mv, cat, grep. We'll look into it as we move forward. Files and directories. So basically, the first thing you need to understand about Linux is everything is a file. Everything that can be represented as a file in the Linux operating system. So all the data is organized into files. All files are then organized into directories. These directories are further organized into a tree-like structure called the file system. So to visualize the tree-like structure, I have this command over here. Okay, that run a very long time. Let me make a new directory. Maybe that'll help. Uh, don't be afraid with the commands. I'll explain them as we go along. So if we do something like lab sheet 1, so this is the tree structure we are talking about. Inside of lab sheet 1, you have a directory called first and a directory called second. And inside first, we have hello.txt. I use certain commands. We will learn what they mean in the next sections. So before that, some basic terminology. The root, the root directory, the node under which all directories and files are stored. A Unix tree has a single root node, the slash character. So if you want to go into here, so if you can see here, it is a slash, a single slash. That's the root directory. That is from where everything else starts. Like every file will be at some level inside the root directory only. Then we have the home directory. Directory in which you will find yourself when you first open the terminal is the home directory. So when I first opened it up, the terminal, so when I first opened up the terminal, I found myself in the home directory. It is represented by a tilde symbol. I don't know if you can see. Okay, I'll clear it up. So this is the tilde symbol I was talking about. This represents the home directory. As for the path, to access a resource in Unix, you need to specify the path of that resource in the command. There are two different paths in Unix, relative and absolute. While relative path refers to the path of a resource from a non-root directory, absolute path refers to the path specified relative to the root directory. So for a basic example what I mean, let's go back to what the directory we created. Uh, so to access, if you remember, we created a hello.txt inside the first file directory. Okay, so to access that, to print out, we can use cat. Okay, now we can access it in two ways. We can say first slash hello.txt. It prints out hello. So first slash hello.txt is the relative path. So relative to lab sheet 1, where can we go? And the absolute path would be a bit long. Uh, to show you the absolute path, I can do one thing. If I go into files and then lab sheet 1 first, hello, properties, it should give me the path. Let's use this. So this is the absolute path, and I'll show you why. So it starts from the root directory. If you observe, it starts with a slash home slash samriddha1, which is my user directory. Then it goes into lab sheet 1, and then it goes into first, and then I can type out hello.txt. So that is the difference between a relative path and an absolute path. So let's get our hands dirty by opening up a terminal. On Ubuntu, it can be opened up by Control Alt T or by simply just going into applications and just typing out terminal. It will just come up. Not an issue. All right. So PWD, it displays the path of the present working directory. So I am in slash home slash samriddha1 slash labsheet1. Okay. Then ls lists the content of a directory, and we can use several different options with it. We'll show you that one by one. So plain old ls, it just shows me first and second. Were I to include a random file into it, so now you can see that a file has been added to the list along with the directories first and second. Also notice the color coding. A file is just normal and first and second are colored blue because they are directories. So along with that you have ls-a. It displays it along with the hidden files. So to show you what I mean, the hidden files are dot and dot dot. So dot represents the current working directory and dot dot represents the parent directory. We'll use these in a moment. So knowing this will help you. ls-l displays contents of the current working directory uh, owner. So it is basically long listing. What this really means is long listing. So it shows a lot of different data for it. Okay, so like what are the permissions this thing has, this file has, and what the permissions these directories have. Okay, and then you can combine options like ls-al. So you have dot file first second, so the hidden files also show up. Next is a command you will be using very often. It's the man command. So the man displays the user manual of any command we can run on the terminal. So right now we have used ls. Let's look at the manual of it. So it has many different options. Yeah. So it has ls dash list directory option file. So what are the options? Dash a is all. So do not ignore entry starting with dot. Then we used L, right? Let's go back to L. Yeah, L. Use a long listing format. We just saw this. And there are a lot of different options. You can just explore them in your lab session. Similarly, you can use this with other commands, man, cat, etc. Please try them out in your lab sessions. Then you have cd, which is change directory. Before that, I will also introduce a command which is very useful, which is clear. CLEAR, clear. It clears your terminal. Now you have a clean working space. So what we can try all of these different options. Cd slash takes you to the root directory. This is indeed the root directory. If I check present working directory, it is the root directory represented by a single slash. If you want to go back to home, you can either use cd tilde, or let's go back to root, and you can just use cd. It will also take you back to home. Okay, so if we go to cd lab sheet 1, we go into lab sheet 1. If you want to go into the parent directory, we are now in the parent directory, which is the home directory. Some more examples. So like if we go to lab sheet 1, now we go into first, and now we go into the parent of first is lab sheet 1. So see here the double dots come into play. So you can use these cd dot. So cd dash takes you to the previous directory. So the previous directory was first, it takes you to first. Then you have mkdir, which is making a new directory. So inside of first, if we want to make a new directory, it allows you to do so. Now if you check with ls, you have the new directory in place. So, and you have mkdir-p, which allows you to create nested directories. So if you wanted to create uh, say another directory which has like third, it allows you, it will not allow you to do that because you've not used the option dash p. So that is the use. Now it allows you. Now you can go into ls. Now you can just cd another dir slash third. It allows you to nest in cd, not an issue. Oh, spelling mistake. Now if we check present working directory, we are indeed in another directory slash third. Okay. Now removing a directory. So rmdir is the command we use. Rmdir dir removes the directory dir provided it's empty. Yeah, this is important. You can only remove empty directories using rmdir. So if we backtrack a little, we are now in another directory. If we use pwd, yes, we are indeed in another directory. If you use ls, indeed there's a third, and third is empty. So if you want to remove third, we will just use rmdir. Wait, let me just rmdir third. It removes it. To confirm ls returns nothing. Uh, Also, we have another flavor of this command, which is rm-rdir, which deletes a directory recursively along with its content. So if you want to remove a directory which has some content in it, you will use this sort of a command. So let's backtrack a little. What does this have? This has file first second, and first has hello.txt. So if you want to delete first along with hello.txt, we can do this rm-r first, and first is gone. Please try these out in your own lab, because unless and until you do these by yourself, you will not get a hang of it. So cat, we have seen this briefly while I was demonstrating some stuff. So cat file 1 displays content of file 1. If I do cat file, that is the contents of the file. Then you have cat greater than file 1. It opens it for writing into it if it already exists. Otherwise, it creates the file and opens it to it. So if you want to demonstrate that, and you will have to press Control C over here to escape the writing prompt. So Control C, and now if we uh, check the contents, it will be file 2. Then cat file1 file2 displays content of file 1 followed by file 2. So something like we have cat file and file 2. Yep, it shows me file along with file 2. Then you have CP. CP is basically copying the content of a file. Pretty straightforward. If you want the same content as file in file 2, so this copies from file into file 2. So if you now cat file 2, it displays file, which was the content in file. You can nest these commands. Try this out in your lab. So it copies the cp file1 tilde copies file1 into your home directory, and cp this. uh, So it copies all files that have their file names with txt as suffix. So this is some sort of a string matching thing. To demonstrate it, let's create a file with .txt. So again, let's create our hello.txt original, which we deleted. And it's asking us to copy it from .txt into a destination, also into destination directory. Okay, so we have the second directory with us, so we can do that. Cp, we have hello.txt here. If you want to print it out, there you go, it has hello. Cool, so let's move on. We have mv. It is used for moving one or more files or directories from one place to another, and also used for renaming. So if you want to move F1, F2, is basically renames f1.txt to f2.txt. So if you want to do that, let's backtrack. Uh, we have file2 hello.txt. So if I want to rename hello.txt, say, now hello is hello2. It was first hello and now it's hello2. Then you have move uh, this file to this directory. So if you want to move it to second, let's do this. Move hello2.txt to second. It's not here now. If we go into second, it's here. You have hello2.txt. And the last option is similar. You can try it out in the lab. Then next comes a word count, WC. It has several different options. You can explore them with man. I can show you. It has bytes, characters, lines, words. Uh, so basically everything you might need for counting lines or words in a text file. You can try this out yourselves, but I will demonstrate it once for our hello.txt. It has one word inside hello.txt. Next command we can try out is head. It prints the top n number of data in the given input. So the default option is 10. If you do nothing, if you give like no options, it will just print out the first 10 lines in file1.txt. Then you have uh, print the next 5 lines. You have dash n 5, or simply dash 5, first 5 lines, and dash c is the byte option. So to demonstrate this, so what I'm essentially doing is creating a new file. Okay. uh, Gedit is also a service you can use with Ubuntu Linux. So if I just do cat new file, you can see it is 1 2 3 4 5. I could have done this with cat as well. I just wanted to show you that gedit as a feature exists. Now if you want to print the first three, so for that you will have to do head dash n 3, first three we are printing, new file, it gives you 1 2 3. Okay. Moving forward, tail is pretty similar. If I replace the only word with tail over here, it should give me 3 4 5. Yep, it gives me 3 4 5. And the last command for today is echo. Echo is something we saw earlier today. Like, it is probably the first command I introduced in this video. So echo hello world, the traditional programming string. Hello world indeed. So for the next part of this video, we will try to solve the exercise. So open terminal in your Ubuntu, you will be at your home screen. So we can just clear it out for now. And probably reduce the zoom a bit. Yep, cool. Create the directory structure given in figure on page 1. Figure in. Oh, they mean this one. Okay, cool. So let's go back to home and create the directory bits. Okay, I'm inside bits. Then we have to create Pilani, Hyderabad, and Goa. Okay, then I have to create Pilani. Wait, I can use the dash p option. Pilani P department CSIS. I can replace this with EC and do the same with Hyderabad. So G department physics PHY. So to verify, yep, works. Just a brief disclaimer. The tree command is something I have installed. The tree command is not available on your own systems, like on the lab. You can download it at your own home systems. Okay. So with that out of the way, we can go into Pilani uh, P department CSIS. We have to create a file1.txt here. Let's just put some dummy text here. Then we can, then we need to go into Goa G department physics. Okay. So CD Goa G department physics. Here also we need to make a cat f1.txt. Okay, so dummy f1. Okay, cool. So we have our structure ready for verification. Yep. Pilani P department CSS file 1, Goa G department physics file 1. Cool. So then first create a new file f2.txt in the ECE directory. So the ECE directory is in Pilani P department ECE. So to give you a flavor of again the relative path, I can do it directly from the bits directory as well. So if you want to do Pilani, this is the relative path. P department, it wants in ECE, and then it wants f2.txt. So the operator, and what do we type in? Okay, new file. Say this is a new file. It is a new file, and if we do tree dot again, it shows up in EC, which is what we wanted. Store the names of 10 students, a random name, and then copy its content into f4.txt of the meg directory. Oh, so it told me what to put in f2. So I can put my own name, then my wingies. Yep, I guess that's 10 names. Then copy its content into f4.txt of the meg directory. Okay, so let's try it once. See, okay, I can, for getting into like, you can, to access the previous commands, you can use your arrow keys up and down. So from here, we want it in the meg department. The meg department is in Hyderabad. So Hyderabad, H department, meg f4.txt. Yep, it exists. Hyderabad meg f4.txt. If we try to print it, oh, my bad. I missed meg. Oh, I misspelled Hyderabad. Okay, so this is my wing. Fine. After copying content of F2 in F4, print the names of all the students starting from the fourth line in the file f4.txt. Okay, so starting from fourth. So you want to print Srijan onwards. So you want to print 7 lines. So the last 7 lines would be using tail dash n 7 Hyderabad. Again, I missed mech. I keep missing this. Okay, starting from the fourth line. Yes, we have achieved that. And remove the EC directory from the tree. Okay, so currently the EC directory has f2.txt. So if you want to remove it, we will have to use the rm command to remove it recursively. So first, let's go into Pilani P department. So now we want to remove EC. So rm dash r EC, confirmed it's gone. Let's back up. Yep, EC department is well and truly gone. So that concludes our lab video. Hope you enjoyed it. Thank you.